Okay, on this one, you're finding all solutions between 360 and 720. So you have to be careful because it's between 360 and 720. It's not our typical unit circle between 0 and 360. So I'm looking at A here, and I'm going to do this without a calculator. So the first thing is, there's a couple ways I want to explain this. The first thing is, I'm going to write these points here. So that would be 1, 0. That'd be 0, 1, negative 1, 0, and 0, negative 1. Now the first way I thought about this, because especially when you're been dealing with math for a while, you tend to memorize things like this. Like I don't say it's important, but it's definitely a bit of where cosine and sine are equal. Okay. Now one of the things I was thinking about is when I just put a random point out here, what are the coordinates of that random point? Right, but coordinates, how would I find the coordinates of that point? We've done this before with theta.
Like cosine theta.
Exactly, that's cosine theta, comma sine theta. Okay, that's how we would find that point out there. So just think about this conceptually for a second. At this point right here, cosine equals 1, right? Cosine of theta equals 1. Over here, what's cosine theta equal? 0. So as I move from here along this circle, it's going from 1 to 0. Now I move at this point right here, what does sine equal? 0. And over here, 1. So think about this. I'm just thinking about moving from here to here. As I move from here to here, cosine is going from 1 to 0, and sine is going from 0 to 1. Wouldn't it make sense that somewhere in the middle there, they're cross each other and they're both equal, right? And it would at least be kind of intuitive that it would be halfway between, because one of them is going from 1 to 0, one of them is going from 0 to 1. And what would halfway between there be? Well, degrees-wise.
Oh, 45.
45 degrees. Now, yeah, that's kind of something you wouldn't think of spur of the moment, I guess. And even still with that logic, you're not guaranteed anything. You know, you're kind of like, oh, I haven't proved that, but it's intuitive. Okay, so let's think about it a different way. What is cosine in terms of trig ratios? What's the ratio for cosine?
Adjacent over hypotenuse.
Adjacent over hypotenuse. What is the ratio for sine?
Opposite over hypotenuse.
Opposite over hypotenuse. Okay, if cosine is adjacent over hypotenuse and sine is opposite over hypotenuse, and we want them to be equal, we can set up that little equation up there. What does that tell you about the adjacent sides and the opposite sides? They have to be equal. So when I think about my triangle I'm looking at, any kind of right triangle with, and this one is a good example, with an opposite and adjacent side, for them to be equal, what kind of triangle does it have to be? Has to be an isosceles right triangle, right? And if I just draw, without even the unit circle, if I just drew the isosceles right triangle and said, okay, I have a right triangle where my opposite side is equal to my adjacent side, oh, that's a 45, 45, 90 right triangle. And that's another way to think about it. Okay? Definitely test worthy as far as where cosine and sine are equal. Okay, so once you have that, 45 is one of the answers. 45 is between, it's not. It wants us to be between 360 and 720. So I'm going to use 45 as my base. So how would I get another angle that's equal to 45? Yeah, I can just do 45 plus 360, which is going to take me from here at 45 degrees and just bring me around one more time. And now I'm between there. And the answer is what, 405 you said?
Yeah.
So that's 405 degrees. Okay. Now, typically there's 2 within one 360-degree turn. So if I look at this triangle, 45 works. Okay. I know my opposite side is that positive or negative? Positive. And my adjacent side, is that positive or negative? Positive. So where else, and again, it's not about being positive though, it's about them being equal. So in what other quadrant will my opposite and adjacent side be equal? The third quadrant. So if I go down here, that same 45-degree angle off of the x-axis,
Couldn't it be in any of them?
it can be any of them, but at those points, at any of the other quadrants, the other two, you would have the opposite side or the adjacent side would be negative.
Why wouldn't it be negative in that quadrant?
Because they would both be negative. This opposite side here is negative, and the adjacent side is negative. All right, for B, because I have this crazy decimal here, I'm going to use a calculator and do arctan of negative 4.3315. And that's going to give me angle T. So what angle did we get there, Kyle? I know you guys got it earlier.
We got, I think it was 7, no, 9. It was, calculator.
Anybody get that?
Negative 643.
Well, what's the angle?
Negative what?
I'll do it.
Negative 77.
So that's negative 77 degrees. Okay? So that is an angle that would work. So if I started right here, where I usually start, and go backwards 77 degrees, go clockwise 77 degrees, that would bring me, we'll just say about right here.
Wait, which way did you go?
I went this way because it's negative 77. And that will work.
Wait, if it's a negative, then you start the opposite direction?
Mm-hmm.
Oh, okay.
Yes, since it's negative, we're going in the opposite direction. That is an angle that would work, but again, that's not between 360 and 720. So all you have to do now is go and start adding. That's 77 degrees, or yeah, negative 77 degrees. If I go counterclockwise and add 360 to it, I'll get back around. The problem is when I go negative 77 plus 360, I still am not between 360 and 720. I'm still not in that area I want, so I have to go around again, add another 360, and then what did you get, Kevin?
We got 643.
643.
Yes.
Okay.
You add another 360 to
So now there's always, I shouldn't say there's always, but 90% of the time there's going to be, or more, there's going to be two. If you are between, if you're not on a coordinate axis, there are going to be two values that are going to be equal there. Yes?
Couldn't you just subtract it from 720?
Yeah, you could have done that. Like, so now you have to find the other triangle. Again, now we're dealing with tangent. So we want to see where else tangent gave us a negative. We're looking at that negative number right there. So the reason that tangent gave us a negative here is because our opposite side is positive, or sorry, opposite side is negative, and our adjacent side is positive.
So it would be the second one.
So the second quadrant out here would give you almost backwards. The opposite side would be positive, and the adjacent side is negative. So now that this is 77 degrees as a reference triangle, Emily?
Is there any situation where all four quadrants would be able to?
Give you the same?
Yeah.
No.
Okay. So
No.
it's gonna be like either the first and third or the second.
I mean, you can have the first and second, or the third and fourth.
How would you
It'll be.
have that?
It just depends what you're looking for as far as sine, cosine, or tangent.
Oh.
Because like in the first and second quadrants, the opposite sides are going to be positive, right? Because they're both above the.
Right.
But the hypotenuse will be positive. So those quadrants, our sines are going to be positive.
Okay.
Okay, so we want that angle right there to the 77. And that angle there is 103, which will also work, but that's not between 360 and 720. So we add another 360. And we get 463. Emily?
Why wouldn't you go from the negative if it's like like, why wouldn't you go like you did 77 and go the negative way? Or would it be the same?
You can go either way. The reason is because the initial answer on the calculator gave me a negative. And I need to be between 360 and 720. That's why I'm adding 360 to get in between there.
Oh, okay.
Okay, so now we're looking at C. It's the same idea as B. We're just dealing with sine now. So with sine, again, I see that I have some decimals. I'm going to do arc sine of negative 0.9397.
This is the last one.
This is the last one on this problem, yes, C. And what does your t going to equal there? Somebody have that already?
Got 70. Not
70, okay.
Negative 70.
Negative 70.
How do you know what t's gonna be?
We're using the calculator.
Oh, okay.
So we have negative 70. So since it's a negative 70, I have to start at my point here and go in the clockwise direction 70 degrees. About right there, we'll say. That's 70. Okay. So since that's 70 degrees, I can think of this angle right here, our angle, which is between, usually we go between 0 to 360. So that angle right there has to be, what, 290?
How do we know the big one?
Well, because we always start and go in the positive direction. And we want between 360 and 720 anyways. So we have to add 360 twice.
270. Or negative 70.
So negative 70 plus 360 gave me that 290 that I had. And then another 360 around gives us a 650.
I just don't understand why you don't subtract 720.
You can do that too. I like that.
It's just like so much easier, but
Well, I think the reason that I don't usually do that is because I like to think about, and I know it sounds nerdy, but I want to think about how many times am I going around the circle and moving around the circle. Okay? Now for the second one, it's not always going to be the same thing. So we need our sign. Our sign's negative here because our opposite side is negative. Our hypotenuse is positive. Okay? Again, sine's opposite over hypotenuse.
the second quadrant.
So you say the second quadrant?
Yeah, because when your hypotenuse be positive and then your opposite, or your opposite would be
Opposite up here
third.
would be a positive.
Oh,
So I'd have to draw this triangle down here.
but then they would both
Yeah, I don't
be
see
negative.
that then. No, because it's height.
The hypotenuse is always positive
How's the opposite negative on the right side to begin with?
Why is hypotenuse always positive?
because the opposite side is the y value.
Oh,
But okay, so on the right triangle, like the right, bottom right quadrant,
Hmm.
why is the opposite negative? Because it's on the positive side.
This is on the negative side.
it's still going down.
I have to go down. The opposite side I'm going down. Opposite side I'm going down.
Why do we?
Or you could think of it in terms of, if you think about it in terms of this point right here, the sign here is negative, right? It goes cosine sine, the sign there's negative, and I need a negative sign. Okay, so I just use that point, or that angle right there, so that'd be 180 to get from here to here, plus another 70, so that'd be 250 degrees.
Subtract from 720.
Add the 360, and you get 5, 6,
Oh, you can just, that would be
610.
Where do you get 250 from?
What's that?
Where do you get the 250 from?
The 250 is from the 180 plus the 70.